Hello everyone. Today we will discuss AWS EKS, Elastic Kubernetes Service. In this lecture we will cover AWS EKS, Elastic Kubernetes Service, node groups and compute options, IAM roles for service accounts, IRSA, EKS networking, and production EKS best practices. AWS EKS, Elastic Kubernetes Service. AWS EKS is a fully managed Kubernetes service where AWS takes responsibility for managing the control plane, including the API server, etcd, and scheduler, across multiple availability zones. This means you do not need to manage the Kubernetes control plane yourself and can focus on deploying and managing applications. EKS integrates deeply with AWS services such as IAM for authentication, VPC for networking, ALB for load balancing, and ECR for container image storage. This makes it easier to build scalable cloud-native applications. Workloads run as pods on worker nodes, which can be EC2 instances or Fargate serverless compute. Standard Kubernetes tools like kubectl, Helm, and Kustomize work without any changes, making adoption simple for existing Kubernetes users. EKS also integrates with CloudWatch for logging and monitoring, and supports persistent storage using the EBS CSI driver. Node groups and compute options. EKS provides multiple compute options to run workloads depending on control, cost, and operational needs. Managed node groups are the recommended default, where AWS handles provisioning, updates, AMI management, and node draining automatically. This reduces operational overhead significantly. Fargate profiles allow you to run pods without managing any servers, making it a serverless option where you only define which pods should run on Fargate using namespaces or labels. Karpenter is a modern autoscaler that dynamically provisions the right EC2 instances in seconds based on pending pods, and also optimizes cost by consolidating underutilized nodes. Self-managed nodes give you full control over EC2 instances, including custom AMIs and bootstrap configurations, but require more operational effort. In real-world setups, multiple node groups are often combined, such as using spot instances for cost-saving workloads and on-demand instances for critical applications. IAM roles for service accounts, IRSA, is the secure way to provide AWS permissions to Kubernetes pods without using long-term credentials. In this model, each Kubernetes service account is mapped to an IAM role using an OIDC provider. When a pod uses that service account, it automatically receives temporary AWS credentials through the AWS SDK. This removes the need to store access keys inside containers or environment variables and ensures better security. It also enables least privilege access at the pod level, meaning each workload can have only the permissions it needs. For example, one pod can access S3, while another accesses a different AWS service, without sharing credentials between them. EKS networking is based on the VPC CNI plugin, which assigns each pod a real IP address from the VPC subnet. This allows pods to communicate directly with AWS services, like RDS and Elasticache, without additional networking layers or NAT gateways. Internal communication between services inside the cluster is handled by Core DNS, which provides service discovery using Kubernetes service names. External traffic is managed using the AWS Load Balancer controller, which automatically creates an application load balancer when an ingress resource is defined. Proper subnet tagging is required for ALB discovery, and security groups for pods allow fine-grained network control by attaching security groups directly to individual pods. In production environments, EKS requires careful planning for scalability, security, and reliability. For scaling, Karpenter is used for node-level autoscaling, while horizontal pod autoscaler is used for scaling pods based on CPU or custom metrics. For observability, Container Insights and Fluent Bit are used to collect metrics and logs across the cluster. From a security perspective, IRSA is used for all AWS access instead of static credentials. Network policies are used to isolate workloads, and the EKS API endpoint is kept private to avoid public exposure. Secrets are managed using AWS Secrets Manager and injected into pods securely. For reliability, workloads are distributed across multiple availability zones. Pod disruption budgets are used to maintain availability during updates, and liveness and readiness probes ensure application health. Resource requests and limits are defined for all containers to prevent resource exhaustion and ensure stable performance. Conclusion: AWS EKS provides a powerful managed Kubernetes platform that simplifies cluster operations while offering deep integration with AWS services. With flexible compute options, secure identity management using IRSA, robust networking, and strong production best practices, EKS enables you to build scalable, secure, and highly available applications in the cloud. Thank you for watching.